Hey guys, so last class we went over what arc length was. Arc length is S, referred to as the variable S, equals your radius times your central angle, theta in radians. So linear speed and angular speed. Linear speed would be if you are a particle running across around a circle. It is the length of the arc traveled in time. So that is the arc length, S, over the time it takes to get around. For angular speed, that is referred to the speed of the angle. So that is theta over time. Theta, be careful, needs to be in radians. So take a minute, hit pause, and write down both of these definitions and these formulas. Linear speed is referring to how fast the particle moves, and angular speed is how fast the angle is changing. Also make note down the bottom, equivalent ratios. Put that down. When we are talking about a revolution, one full revolution is one circle, so that would be 360 degrees, or 2 pi in radians. And if you need to know length for that, if they are talking about one revolution and they don't give you the distance for that, it would be 2 pi r. All right, I always find that examples help me out. So if you need to, hit pause again and finish writing that equivalent ratio at the bottom. All right, the seconds hand of a clock is 10.2 centimeters long. So the seconds, that is talking about this red one right here, the one that we are watching tick around until it hits the 12 for the bell to ring. So it is 10.2 centimeters long. That is the radius. Find the linear speed of the seconds hand in centimeters per second. So linear speed is arc length over time. So we have to find the arc length. They gave us the radius, and we need to find theta. Well, we have to use a real world example for this. So this seconds hand ticks around all the way around a circle. So that is making one full revolution. So one revolution in 60 seconds, because they said seconds here. So S equals R theta. Well, R is 10.2 centimeters, and theta is going to be, one revolution is 2 pi in radians, from our equivalent fraction on the last slide. And time, they told us we're using seconds, so 60 seconds, and this up here was centimeters. So once again, this is arc length, so S is R times theta. R is 10.2, theta is one full revolution, so 2 pi in radians, and then 60 seconds. So multiplying all of that out, what would you get? Let me look here. That would be 20.4 pi over 60. Have to multiply pi out. So this is approximately 1.07 centimeters per second. So that would be the linear speed of the seconds hand. All right, let's look at another one here. The blades of a wind turbine are 116 feet long. The propeller rotates at 15 revolutions per minute. Find the angular speed of the propeller in radians per minute, and then find the linear speed of the tips of the blade. So if something was right there, what is the linear speed of that? So angular speed, AS, angular speed is theta over time. And in this case, they give us a specific thing that's happening, 15 revolutions. So theta is going to be 15 revolutions times 2 pi. Over time, and they want it in minutes, so you would just write 1 minute because they said per minute. So here, the angular speed would be 30 pi radians per minute. You can leave it that way unless they ask you to rewrite it in anything different, but for angular speed, you leave pi in the answer. For linear speed, notice angular speed, they had nothing to do with the radius. I did nothing with the 116 feet. For linear speed is arc length over time. So arc length is radius, so 116 times theta. The nice thing about this one, if you have angular speed, you already know what theta is, but theta is going to be your revolutions times 2 pi. In this case, we already know that that's 30 pi. And over time. This one here is nice because they wrote 1 minute and they asked for linear speed per minute. For this one, for linear speed, you need to multiply out pi. So take a minute, hit pause, and multiply out 116 times 30 times pi. All right, so this one here would be approximately 10,933 feet per minute. All right. So this one seemed a lot simpler because they already said per minute, and we were asked to find things per minute. Be careful. The trickiest thing for these word problems can be if they were to say, you know what, give us the linear speed in feet per hour, then you would need to do a conversion from minutes to hours. And the other thing is whenever they tell you a revolution, since you're dealing with radians, you always multiply that number of revolutions by 2 pi. I hope this is helpful. Always go back and rewatch it if you need to, and please let me know if you have any questions. Thanks, guys.